Algorithm is a sequence of unambiguous instruction to solve problem. When you divide a number, if you get the remainder, that is the answer for the mod. Once we finish that diagram, now we will explain each and every step. Very first step was understand the problem. What is pseudocode then? It is a combination of programming language and my natural language. Hello all, myself Evelyn Jacob, working as a faculty in BCA department, Vidhyaashram First Grade College, Temple of Excellence, Mysuru. Very first unit, that is introduction. We already discussed the topics and the syllabus of it. These are the topics which is covered in unit 1. So very first concept is what is algorithm. So the definition of algorithm, how to write an algorithm in the introduction. So what is algorithm? When I say algorithm, we have to define it. Simple definition is step-by-step procedure to solve a problem. But according to your textbook, the definition is what? It's a sequence of unambiguous instruction. Sequence of unambiguous instruction to solve a problem. So what do you mean by unambiguous? Means you don't have any doubt. That is without doubt. Or another word for unambiguous is no misunderstanding. Okay? So I give you a problem. If you don't have any doubt, will you able to solve it? Yes, of course. That is what about algorithm. Algorithm is a sequence of unambiguous instruction to solve problem. So whenever we write a code, whatever we do is, we'll write a computer program. Till now you was writing directly a program. For that, you'll be given input. Say I'll give 5 and 6. Say I want to add it. Okay? I'll give the input 5 and 6. What is the result? So 11 is my output. That is the result. This is the computer program. For the computer program, it needs input and it will give you what? Desired result. For the computer program, what we have to do is we have to write what? Algorithm. So where is the algorithm? When you give a problem, you find a algorithm. That is, once the problem to be solved is written in the form of algorithm, the algorithm will be converted into programming language. This is about algorithm and small diagram of algorithm. Next, so what are the characteristics of algorithm? When we come to know the definition of algorithm, it's the time to know the characteristics. So very first characteristics, when we saw in the previous image, what is it? The program is there, you'll give input. So every time it need not to be given an input. It can have 0 or more input. Okay? That is what about input. Next, what is output then? I'll give you some input. I'm waiting for a result. That is output. So at least one output. Next is definiteness. So when I give you some word, you may define it. So it is clear. So that is definiteness. So each instruction should be clear, clearly defined and no doubt. So what I say doubt in the word unambiguous. Okay. Next, what are the next characteristics? It is finiteness. See, I want a result should be finite step. That is finite number of steps. I can't write an algorithm pages to pages together. The meaning is number of steps should be limited, finite. It should never be infinite. At last, we go to an algorithm which is very efficient. So algorithm should be efficient. That is, what do you mean by efficient? It should run in short time. Okay. So then how to write an algorithm? We came to know the definition of algorithm, the diagram of the algorithm, characteristics. Now it's time to write an algorithm. So Once you know the algorithm definition, then know the steps how to write. See, where the algorithm, whatever algorithm is given, the two sections will be there. One is head section. Okay? We'll give you what the algorithm is. We're going to specify what it is all about. Next is the body section. Okay? One is the head of it, of algorithm. Next is body. So what is there in the head section? I already told. Head section gives you the first keyword algorithm. You have to write algorithm with the keyword, correct spelling. Then I'll write the name of the algorithm. What algorithm is? I want to multiply. Then I say algorithm multiply, or I'll say multiply, a short term. Okay? This is keyword. You can't change. This can be changed based on your program. Next is the parameter list. If suppose I want to add two numbers, I say how many parameters? 2. In this example, what we have did, we want to multiply. So, two numbers or more than 2 also. That is what is called parameters. Next, this is head section. We write algorithm, we define the keyword. Then what is this? This is problem description. We'll say this problem is about multiply 2 numbers or 3 numbers. Then what is the input given? Say 2 numbers, say A, B. What is the output? Is the product of AB. This all comes in where? In head section. In head section, first we wrote the keyword algorithm and with the algorithm name. Then is the input, output. Before that we gave the description of the problem. Next is the body. In the body we act as a code for writing this all statements, say if, while loop and all. So what is this if, while loop? If you studied any programming language, you know how to write the statements. If I say condition, if A is greater than B, A is the greatest. Else, which is the greatest? B. That is what about body part. It is the actual content or actual coding of it. Next is the in steps. It's not only if and statements, more statement is there, more constructs is there. So what and all is there? Even if you write if statement, there is an end if, end for. If you write for, you have to end it. Or you can end with the flower bracket. Then you have the comments. What are the comments? Comments is not executed by the programming language. Then who will this comment? Is the we, the user. If I want to describe, this is all about multiply. I will write the comment in double slash. So this is the comment statement. So whenever you open an algorithm, you will read the comments. This will do certain things. So it is easily for us to understand. Next, this is the left arrow. I already told y'all will multiply or sum or whatever it is. If suppose A is equal to 5 plus 6. What is the answer? A is 11. But when you're writing the algorithm, you should never use equals. Assignment operator is not used. We have to use which symbol? Left arrow symbol, and then 5 plus 6. This is all about the assignment. Next, you have an array. See what input? See, for 2 numbers, A plus B, I don't use inside an array. If there are more number of elements, so collection of similar elements, what I do? I'll use in this array. So there are lot of statements. Say another statement is there, read and write. I want to read the number from the keyboard. What I'll use in C? I'll use scanf statement. Similarly, there are a lot of programs. Depending on that, you have to write in the body section. So now we go for an example. What example? We go for an example to write an algorithm, that is Euclid algorithm. Euclid algorithm to find the GCD. What is GCD of? GCD full form is greatest common divisor. So how to write an algorithm? First, what I told, we have to write the keyword algorithm. Okay, no spelling mistakes. Then write a algorithm name. What algorithm? That is your choice. If you want to make it shorter, you can write E_GCD. Or to make it clear, you can write full of it, Euclid_GCD. See, GCD we know that is greatest common factor. We'll take how many arguments, how many input? Say M and N. Okay. So what are these? Are all what? Comments for us to read. They say computes GCD. We have to compute GCD M, N by which algorithm? By Euclid algorithm. So what is the input then? So we have to take two integer. What type of integer it is? It is non-negative, mean positive. So it takes two non-negative integer. And what is the output? If you give two numbers, I want to calculate the GCD of the two numbers. I'll get what? GCD. This is the code of it. This is the body section. I'll write the code of it. So how to compute this code? See, there is formula for it. How to write? First, I'll write GCD. GCD of M, N. You have three statements. What are the three statements? Suppose I'll write GCD of N, M. When this will be happened is if N is greater than M. Okay. The answer will be M if N is 0. Okay. Another case is there, that is otherwise. What happens in otherwise? We have to calculate the GCD of N, mod of M, N. Okay. Mod of M, N. This is the formula or algorithm to calculate GCD. Suppose I'll give you an example how to calculate. Suppose I'll do GCD of two numbers. What are the two numbers? Say 60, 24. Okay. Now 60 is M. What is 24? 24 is N. Now I have to check the condition is N is greater than M. N is greater than M. True or false? False. N is 0? No, my N is 24. Then I'll calculate using this. How to calculate is GCD of what is N here? N is 24. I'll write 24. Then I have to calculate the mod. That is 60 mod 24. Again, I'm going to write GCD 24, comma. Now I have to calculate 60 mod of 24. What is mod? When you divide a number, if you get the remainder, that is the answer for the mod. See, if I'll divide this, 60 divided by 24. 24 2s are 48. So 60 minus 48 is, what's the answer? 12. So that is the remainder and that is the answer for 60 mod 24. Against 24, 12, again we have to split GCD of N. What is N here? N is 12. Again write GCD of 24 mod 12. So GCD of 12 is written as it is. What is the 24 mod 12? When you divide 24 by 12, what is the answer? 12 2s are 24. What is the remainder? 0. So now N is 0. When N is 0, what is the answer? M. Where is the M? M is here. So what is the answer for GCD of 60, 24? The answer is 12. This is done using this code. See, till here it is all comment. What is this? While N is not equal to 0. If it is not equal to 0, what we do is M mod N is assigned to R. Is similar to R is equal to M mod N. Okay. Then the value of N is assigned to M. So we'll get the answer, whatever the answer for the mod R will assign to N. So this process will continues until N is equal to 0. If N is equal to 0, you have to return M. is similar to this. We have written the 12. If you want to calculate using mathematics, how will you do? You'll take 2. Say 60 and 24. 2 30s are 60. 2 15s are 30. 3 5s are and 5 1s are. 24 is 2 12s are 24. 2 6s are 12. 2 3s are 6. Next 3 1s are. So what is, if I take 60 and 24, how much should I get? 2 into 2 into 3 into 5. 2 times 2 and 3 and 5. If I take this 24, it is 3 times 2 and 1 3. So what is common here? If I say this much is the common, right? And 3 is common. So I can write 2 into 2. Here is common, 2 into 2. Here 3 is common. So what is the answer I'll get? 2 2s are 4, 4 3s are 12. So this is proved. According to GCD also I got 12. According to my mathematical also I got 12. This is the GCD algorithm. So we have written an algorithm by using GCD and calculate that value. So it is true. Next is the fundamentals of algorithm. Once we have known the characteristics of algorithm, written an algorithm for GCD, and what is the fundamentals. When we write an algorithm, what should we keep in mind? So very first point is understand the problem. So this diagram tells you what is the very first step. What is the problem? How should I understand it? How should I go into it? Then what are the computational capabilities? If I write an algorithm, is that algorithm suitable for my computer? That is decision making. Next, after when you decided that algorithm, next you have to start with the designing of the algorithm. Once the design is over, we have to check whether it is the algorithm what you have written is correct. Any proof? As we check for the GCD, we have proven the value is correct. Then we have to analyze in terms of efficiencies. Only then we can say algorithm is perfect. At last, we have to code. Code what? The algorithm. We convert the algorithm into what? Programming language. Once we finish the diagram, now we will explain each and every step. Very first step was understand the problem. See, when I give you a question paper, what will you do? Read once or twice until you understand it. Once you finish understanding, what will you do? You will write the answers. Similarly, the very first step in the design is read the problem. You keep on asking the questions to yourself. What are your doubts? How can I understand it? The very first is understand the problem. What are the problems? What may be the input? What may be the output? It will all come in the first step, that is understanding the problem. Next, decision making. See, when I give you an algorithm, you should know what are its computational capabilities. What is computational capabilities in terms of speed? See, when I give the algorithm, you should check how fast your computer runs for that program, how much memory it's taking. Okay, that is decision making. Next is you have to choose between exact and approximate. See, for a calculating GCD of 60, 24, you know the exact answer. What's the answer? 12. But if I say weather prediction, can you give the exact answer? No, it is approximate. So you have to choose between exact and approximate. Next, you have to choose the which algorithm technique shall I use, what design technique. You have many algorithms. Should I go for a brute force or a greedy technique or divide and conquer? That is selection based on your algorithm. In this scenario, you'll get into what is the computational device capabilities and choosing design techniques. Next, see, I want to specify an algorithm. I'm conveying to y'all in which language? In English. That is what about natural language. How to specify the algorithm? Only English is enough? No. I need to add little programming code. So what I say, that is pseudocode. What is pseudocode then? It is a combination of programming language and my natural language. Then if only sentence is boring, then we'll go for what? Flowchart. What is flowchart? A pictorial representation of algorithm. It will have all the symbols. It is nice to see. Even you can read, even you can see the symbols. That is all about flowchart. Next, I already told what is natural language. Natural language, it is very simple to understand because the language which we know, which we talk, whenever we read, it is easy to understand. Yes or no? Yes, right? That is natural language. It is simple and easy to specify. If I say, write an algorithm to add two numbers, what will you do? You start with the steps. So step 1, you can start with start and end with stop. Okay? In between, these are the steps you have to write in what? Natural language. First, you should read the first number, say A. I'll read the first number A, say 5. Next, I want to read the second number B, say again 6. So what I have to do? I have to add these two numbers. So add the two numbers, then where shall I store the result? In which variable? I will store in the result C. So the step 4 will display the result C. So C will have result what? 5 plus 6 is nothing but 11. We have written an algorithm. In which language? In natural language. See, when I see this algorithm, anybody can understand. Even they don't know the programming language, you can understand. That is what I meant to say about natural language. Next is pseudocode. Pseudocode is the combination of what? Programming language and natural language. See, this is the programming language and natural language. It is a mixture. It doesn't mean only program is there. You have little English sentence also. Natural language. Okay. Then how to write a pseudocode? This is a pseudocode. Yes. Why yes? See, from the starting till the ending, we write the comments, we'll write some English language, we'll write some code. A mixture is nothing but it is a pseudocode. How to write an algorithm? It should begin with the keyword algorithm. Next is the algorithm name. I give sum, but I don't want sum. I want to give any other thing. You can say add. I'll give add. This is your own name. Next, I'll give two arguments A and B. Okay. Next, what are these? This is comments. Okay. This problem description, I'm going to describe the algorithm. I'll write it to add two numbers. Okay. Then what is the input? To add two numbers, I need integer. Integer is nothing but a whole number. Even I can add float also. If you want float, you give to float. What is float? Decimal number. Say example 3.5. Then what is output? Output is addition of two numbers. For this, what is the answer? If I give 3.5 plus 5, it is 11.5. Okay. Next, to add two numbers, what statement should I use? I use C. This is assignment operator, left arrow operator, A plus B. Then finally, I will return what? The result, which is stored in where? In which variable? In C. Next is the flowchart. I already told flowchart is a pictorial representation of algorithm. So, you can say pictorial, you can say graphical representation. Whatever sentence we wrote in step 1, inside the symbol. So, we have to know what symbol to use for which it is used. Okay. So, for start and stop, I use this eclipse symbol. Okay. For start and for stop. For both, I will use this symbol. If I want to do some operation, say add, multiply, I will use this symbol, that is rectangle symbol. Next, if I want to enter the input, get the output, that is all this symbol, which is parallelogram. Similarly, you have many symbols. Depending on the program, you should write what symbols. But basically, these are the symbols: start, stop, and parallelogram for input, output. rectangle for processing. Okay. Suppose if you need some conditions, say if statements, that can be written inside what? Diamond shape. Then we'll write an algorithm. We already wrote an algorithm for addition of two numbers. Now it's time to write what? Flowchart. So how to write a flowchart is start and stop is there. In between these we have written separately. If you want to combine, we have to follow with a arrow mark. Okay. This shows the step-by-step procedure. First is start, last is stop. And in between is the content of it. First what we do? We'll read the value. Say input the value of A. Next, B also we have to input. Means you have read the values from the keyboard. Next, this operator what we do is C is equal to A plus B. When we add, the result is stored in C. That is written inside a parallelogram. So you can see what are the symbols used, how it is used. Instead of writing steps, we write the steps inside where? Symbol. That is all about flowchart. So now, once the algorithm has been specified, we have to prove the algorithm. Okay. That is also important. So correctness is being proved. Every time we can't take GCD of algorithm. It can be anything. GCD is a simple algorithm. We have to cross check whether it is correct, whatever were the errors, what can be changed. Okay. Very common technique is we use mathematical induction. Okay. To solve algorithm to prove its correctness. Okay. Next. So when we say analyze the algorithm, next step is the analyze the algorithm. Analyze the algorithm in terms of what? In terms of efficiency. There it comes two terms, time and space. When I want to run an algorithm, we have to check algorithm will run faster. If it takes long time, then this algorithm is not efficient. Then space. See, finally we'll convert the algorithm into coding, right? Whenever code will run, we have to check whether the memory space occupied by the algorithm is less. If it is less, then it is efficient algorithm. Next, so coding an algorithm will tells you once an algorithm is done, the very thing is we have to convert into a programming language. So which language you are familiar, you can convert it. Which language you all know, say C, C++, Java, Python. But in your subject, which language will you use in your lab? C. So we'll go for a C. Okay. Still, if you want other language, you go for a C++, Java, Python. Okay. This can be used. So in coding a programming language, it depends on the algorithm. Sometimes some programming language you may find difficult. So always you prefer to the programming language which is easier, and you'll get the desired result. Okay. Next, so in this you have very looping expressions also. What loops shall be used, which is more convenient. So ultimately the problem is to convert to code. In order to understand that, the coding should be efficient. Okay. So what and all operations can be used and which operation is okay based on all the constructs. Once you have analyzed, once you have designed, decision making, everything is done. Now is the coding part is done, which programming language to be used and which is efficient. This will play a very important role. Okay. Ultimately, it is one, we have to search this programming language or which is better. Then what and all other points we have to consider while coding. If it is inefficient, if suppose we write everything is sorted out, whether the code is inefficient, then we have to move on to the next programming language. Thank you for the session.